All right, going live again, and this time it is February 20th, 2025. And so we are going to go live and see what happens. So we are talking about the abacus, and I wonder how it would look if I could see it. Hi, Stare Guy. How you doing? I'm talking about the abacus. And Danny Marie, hi. Hi, everybody. My name is Lynette, and we're talking about the abacus. Hey, Moo Corals. We're talking about the abacus. What's the abacus? It is this thing right here. It helps children to figure out how to count on the abacus. And so what we're going to do is we're going to learn how to count. Easy, right? It'll be 1, 2, 3, 4. Hi, welcome, 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 Mikey and Jill and Daddy. So, how do I know? Well, whenever the beads are touching the beam, this beam is what makes the beads counted. So what we're going to do is we're going to count. 1, 2, 3, 4. So we have 4. But notice we don't have any 5 bead. We don't have the 5th bead. So the 5th bead is actually on the top. This has a value of 5. Hey, bud, how's it going? Ooh, I like that. And Mimi Machine. Hi, Angie. So this has a value of 5. When we continue, remember that this is a value of 1. So when we bring it together, it's 1, 5, 6, 7. How do I know? Because we have the value of 5, and then these are the values of 1. So it's 5, 6, 7, 8, 9. Hi, everybody. Hi. Welcome, welcome, welcome. And what we're doing is we're talking about the abacus. And I'm not sure how many people are in the room, but we're going to keep going, because I'm doing something different now. So we have our ones, right? We talk about the 9, and then here is the 10. How do I know this is 10? Because just like how we write on the paper. Oh, I don't have paper. Just like how we write on our paper, we have our 10. So we have 1, 2, right? We have 1, 2, and then 3, and then 4, and then 5. So this is 5. We have 10. 10 is this. Notice it's a 1 and a 0. Just like how we do this. 10s and 1s, right? And then we have 11, 11, and then 12. Now, if you notice, I actually start here. Hi, everybody. Hi, everybody. Welcome, welcome, welcome. That's a lot of amount of people. I'm not sure how many people are here, but I see a lot of people joining. Hi. So what we're doing is we're counting. And so notice, if you could see, I have these dots. Anybody know? These dots are what tells me where the ones place is. Anybody have any questions, let me know. We're going to continue on, and we're going to actually start doing some adding, subtracting. Maybe if there's enough time, we'll do multiplication and dividing on the abacus, and I'll show you how to do that. So we have our little dot here, and this little dot tells us, that this is the ones place. And if this is the ones place, then we know where it's all labeled. Thank you so much for liking my live. What we're talking about is the abacus. And so we're going to continue to count. We have our ones here, and then there's this one here. You can actually use any one of the dots. It doesn't matter which one. You can do this one or you can do this one. I chose this one because then I can have a bigger number. What does that mean? Because it'll be ones, tens, hundreds, thousands, and 10,000, right? So then here, if you notice, there's a dot here. This tells me the ones. Now I can actually write the decimal place. So what does that mean? Well, if I have a decimal, I don't know, 25.75, right? That was horrible handwriting. 5, right? 25. How do I know? 25. We have the ones and we have the 20. I'm sorry, the tens. And then if you notice, this decimal does not take a place value, right? So it sits between the two columns. So that's what this is. So then we do 75. Does that make sense? Everybody's tracking? So thank you for joining. Thank you for joining. Let me know if you have any questions, and I'm just going to continue on. So I have a question for you, actually, I have a question. If we know, so let me do a fast counting. We do 1, 2, 3, 4, right? And all the top bead will be 5. So this is 5, this is 5, this is 5, this is 5, and this is 5. These are all 5s. Now, but the difference is this is 5, but don't forget this is 5 and a 0. This is 50. So then this is 500, and then this is 5,000. So my question is, who knows what this number is? Go ahead and put in the chat what this number is. What do you think this number is? Oh, I do like this view better. I'm happy that this happened. So let me know in the chat, what number do you think this is? Hi. Hi, Camellia and Jewel and Baba Ganoush. Oh, I like that name, Baba Ganoush. Anybody? What number is this? What number do you think that is? Go ahead and put it in the chat. Hi, everybody. Hi, everybody. Welcome, welcome, welcome. 9. Don't forget, there's this one over here. So don't forget, 35. Well, 35, we have the 5 here. So we have 30, which is good, and then the 9. So if you combine them together, we get 39. So our answer is actually 39. How do I know? Because I have 3, and then I have 9. 5, 6, 7, 8, 9. So this whole number is 9. This is 5. So if it was 35, it would be like that. Or if it's 81, so what does 81 look like? 81 looks like this. This is 80, and then this is 1. Thank you so much for the question, for the answers. I really do appreciate it. So now we're just understanding how to read the abacus, right? We all start from reading the abacus. I mean, I started from reading the abacus. I didn't learn abacus when I was a kid, but we all have to learn how to read the abacus. Once we learn how to read the abacus, then we can easily go into adding and subtracting. Thank you so much for liking my lives and joining and sharing and so forth and commenting. It's really nice to know that I'm not the only one just talking about abacus. So let's do another question. Let's do another number, not a question. Let's do another number. So let's say our number is, this one. So we have this number. Okay, there. So it's a 4-digit number. What number do you think that is? Go ahead and put it in the comment. Let's see if I can make this a little bit better. How about that? Is that better? So it's not so confusing. So what number do we think this is? I got to make sure that all of my beads are not touching the ones that I want to touch, right? So we want to make sure that these are the only beads. So this is a 4-digit number. We have our 1s, we have our 10s, we have our 100s, and we have our 1000s. Yes, Rancid Takes, exactly. So it's 1,582. That is fantastic. However, is that really it? Or if I have this as the decimal place, as the ones place, what number would it be now? Because we had this as the ones place. What is the ones place if it's this one? And that's easy, right? Yes, exactly. So this answer would be, you're absolutely right. I'm just going to reiterate it. 1.582. Exactly how it is, right? Easy. And so when we talk about this, it's it's interesting to see how it's being, portrayed. Okay, so I guess we're ready for some adding and subtracting. So the biggest thing is, in this book that I have, we start off with learning how to do the numbers, right? And once we understand how to do the numbers, this is for preschoolers. So this book was meant for children that are 4, 5, and 6, and they're still learning how to do their numbers. But I have it where they have their exercises and trying to reiterate and reinforce the idea of what the number is. And I have it where, they trace the numbers and so forth. So they have to practice like writing, right? Because we're always on the computer. So it's kind of difficult that they don't have enough time to like practice their writing. So I have them to do their writing. And I also have some other activities where they start coloring and stuff. So as they color, they know their numbers. And after that, then they start drawing and understanding how to count forward and then how to count backwards. So it's easy. Oh, that was the one thing. It's easy to see the counting backwards. Why? Because we know when we count forward, we're adding 1, right? When we're adding. So we're 1, 2, 3, 4. We add the 1 bead. Then when we actually count backwards, the children will see that we're just moving this 1 bead out. So as we move the 1 bead, they start to understand that that's what subtraction is. That's what taking away is, because they know that once we have the beam that counts the beads, we know that when we take away the 1, it's a subtraction. So there's no confusion for the children when they do adding and subtracting, which is really kind of amazing, right? Like, I think it's pretty cool. I heard that in regular school, they actually teach subtraction like the second half of kindergarten. And I'm like, what? Why is that? Thank you so much for following my live. Okay. So so now we're counting backwards, and then the idea for this one was, try to figure out how to count backwards and get the kids to understand. And then after that, I have it where they will know like what comes in between, what comes before, and what comes after. And these are all just exercises for them to just have a better number sense and also understanding how to utilize the actual abacus. So this is more abacus driven, right? Like what's bigger than and what's less than. I wanted them to see the numbers and so forth. And I want them to practice their writing. And so that was a thing. And then this is again just another drawing thing, right? So here's the number. What number is less than this number? What number is greater than this number? So that was the idea for this. And then finally we get into adding and subtracting. So this is where we do adding and subtracting on the abacus. Now the reason why we do +1 is to show the second add-in, right? We focus on in abacus, which is the gateway to more complex math. We actually focus in on the second add-in. What does the number do when we add it? What does that mean? Well, when we do 5, right? We have 1. Well, that's the 1. So when we're doing this one specifically, it's only adding the 1 bead. But the 1 bead can be any one. It's not necessarily the green bead, right? It's sometimes, if it's 6, I want to add the 1 bead. So the idea was to show the children that when we do 1 bead, we only talk about the 1. So when we do 7 plus 1, well, notice my yellow bead's already up there, but I have an orange bead to move up. So I can use the orange bead to move it up. And then, again, if I have 8 plus 1, I only need to move the 1 bead. So the idea here was just to know that when we want to move the 1 bead, that's what we're doing. When we do this, let's say there's 4, right? This is not a question in this book because now we have to figure out how to use this 5. And that's a different technique. That's a different formula. But then if we go on, we can talk about, and then, again, it comes with exercises and activities. So now we have a +2. If you have any questions, let me know. I'm here to help and I'm here to answer any questions you have. I'm just going to continue on with the book just to show like what we're doing in Abacus. And so it starts easy, right? Obviously it starts easy because it doesn't make sense to like try to be able to read this. So as we go through, we try to understand how to read and move the beads. When we move the beads, it's easier to subitize. Now what is subitize? Subitizing is knowing what the numbers is knowing what the numbers are, right? So some of the manipulatives that's being taught in school is that they use a die, and the die is to help. They say, oh, okay, this is 4. So instead of counting 1, 2, 3, 4, the kids will just know that this is 4. So the idea of subitizing is that if you see the number, you know what it is. You see the item, you know what it is. And so if I do this, we know that this is 5 because it's a top bead and the top bead is touching this beam. So this will always be a 5, which we know that on a die, this will be 5. And then we have 6, right? So instead of counting 6, 1, 2, 3, 4, 5, 6, we're counting, we don't actually count 6. We break it up in our minds, 3 and 3. Well, on the abacus, it's easy to see that this is 6, right? So if this is 6, but the funny thing is, the die only goes up to 6 sides, whereas on the abacus, it goes higher. It goes to 7. And then when I do this, right, it's easy to see that this is 27. Okay, so that's what subitizing is. Subitizing is when you take a look at the number, you can take a look at the number and understand what it is. Anybody have any questions? I am here and we can talk more about abacus, and now we're going to be adding. So going back to here, this is adding +2. So again, what we're doing is we have 7, so I take this one, right? My number is 7. I just need to add 2 beads. So the idea is understanding that any 2 beads, but as long as it's 2 beads, get touched, so get added. So when they get added, that's what the answer is. So the answer is, anybody know what an answer that is? Oh, I wrote the answer there. Anybody know what this answer is? Go ahead and put in the comment. Hi, George. Welcome, welcome, welcome. I don't know how many people are here. Okay, so anybody know what this answer is? This is 9. Hi. Okay, so this is 9. How do I know? Because it's 5, 6, 7, 8, 9. So when we count 1, 2, 3, 4, and then 5, 6. How do I know? Because this has a value of 5, and as the value of 5 touches this beam, it's 5, 6, and then it's 7, 5, 6, 7, and then it's 8, 5, 6, 7, 8, and 9, 5, 6, 7, 8, 9. So this is 9, this is 9, this is 9, this is 9, this is 9. So these are all 9s, but it all depends on the place value. So now on the abacus, we actually know what the place value is. I will start at this dot, and this dot is my ones place. Thank you for the follow. So this is my ones place. How do I know? Because there's a dot. This dot helps me label where I want to start. I can start here or I can start here. But if I start here, then I have my ones, right? And then I have my tens, I have my hundreds, and I have my thousands, and I have my 10,000. But when I do that, this is 9, and then this is 9. So this is 9. This is 90 because it's a 9 and a 0. And then if I look, this is 900. Hi. Let me know if you have any questions. Anyone that you have any questions on the abacus? And then this is usually, I'm trying to start the children that are 3, 4, and 5 who starts to learn how to read and learn how to count, to try to start them on the abacus, because I was hoping to get them to have a stronger number sense. And so that's why I built this book. Thank you so much for liking the live. So that's why I built this book to bring young children like 3, 4, and 5. They're starting to learn how to count. And so what I wanted to do is I wanted to show them that this is the number 7. And then on the abacus, this is what it looks like, the number 7. How do you use one? So let me start off with, so what's a 10? One green and, okay, so what's a 10? Well, just as we have here, if this is our ones column, this is 6, 7, 8, 9. Now, this is our ones column. 10 is this. Just like how we write 10, right, on our tens, and this is our ones. So this would be 10 and 1. But we have to make sure we understand what the dot is. I'm going to invest in an abacus too. That's fantastic. Yeah, it's one thing to understand how to do it. It's another thing to to get the kids to understand. I have 3 boys, and they've all gone through the abacus curriculum, and they're super great with their number sense. So going to how do you use one? Well, lost my wrench. This is how you use it. So when we count, it's 1, 2, 3, 4. All these beads that are below this beam, this horizontal bar, has a value of 1. So with the value of 1, we have 4. But when we have the top bead, this will always be the value of 5. For my boys. Yeah. How many boys do you have? I have 3 boys, and I yell a lot. My oldest one is 17. Whew. It's been a while. It's been a minute. But I actually didn't start learning the abacus when I was a kid. I learned abacus as an adult. Like, it was one of those things, like my dad went to a business trip and he was like, "Oh, this person said you might have to bring." Oh, your oldest is 15. Aw. Yeah. Sorry. So my dad went to a business trip, and this lady was like, "My kid is autistic, but he does really well with the abacus, and it's the greatest thing next to sliced bread." And then my dad had the epiphany. He was like, "My grandkids, even though I don't have any, my grandkids I want my grandkids to learn the abacus because I think it's next to sliced bread." So he put it upon me and my brother to learn the abacus, and whew, it's a journey. I've been teaching abacus for more than 20 years now, and it's been interesting because we started off with learning how to do the abacus, but I'm actually on the path of trying to relate it to mainstream math. And so why do I want to do that? Because this is actually very close to what we're doing. So in school, when we start talking about the 5 frame, so students are being taught how to use the 5 frame. We know how to do the 5 frame. This is a box, and if you color in 4 boxes, right? If you color in 4 boxes, what is the next box over? Are they all the same, even the bigger ones? Yes, they are all the same, even the bigger ones. I will show you. Let me continue my thought. So notice I have 4 and then 1 will always equal to 5. And then in school, we still talk about how 1 and 4 is equal to 5. Well, that's great. That's great. But in Abacus, we actually take it one step further. So there's a bunch of manipulatives, right, that we're using in school. One of them was a die, the other one was in blocks. So the question was, is there a bigger one? Yeah. So this is the medium-sized one, and this one, it's made out of plastic. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 columns. And it works exactly the same because it's just the positioning of the beads. So if I line it up, so the reason why I would start in the middle, because now it's bigger, right? Whereas the small one, it's nice for the younger kids and it's also more colorful. My class that I have is an online class, and it's easier to tell the kids, okay, move the yellow bead as opposed to move the brown bead. All right. So, but you know, if you're in person, it's easier to see. If it's in person, it's easier to direct the kids, right? So it'd be the same thing. We would count 1, and then 2, that would be 2. So I'm going to line it up together like this. So 3, 3, 4, and 4. See how all these beads are touching the beam? These beads are touching the beam as well. And then this is 5, and then this is 6, right? 7, 8, and then 9. And it's the same concept. Now there's an even bigger one. I think this is 23 columns, and this is more competition abacus. I don't teach competition abacus because it's really stressful. And I mean, there's a bunch of kids that do a bunch of numbers and stuff, but my goal was to just get the kid to be comfortable with understanding what math is and the numbers and be strong with their number sense. So yes, so there is this one. There is a Chinese one too that we can talk about. So this is a Chinese one. How do I know it's Chinese? Because it's 2 beads up top and 5 beads on the bottom. It's a little bit redundant. And so what the Chinese people did, so anything behind the lady dot is cents. I'm sorry. Anything behind that lady dot is cents. Yes. Yeah. Yeah, last. Yes. So you're right. So what happens is, if this is the ones, right? Just like how we write our numbers, notice that our decimal does not take a place value. So when we do this, the question would, the answer to this, I don't have enough beads here, but it would be 1, 5, 8, and then 2. I could do it here, right? Because I start in the middle, I can have more to the decimal. So I should clear my abacus. So I clear my abacus. I do 1, 5, 8, and 2. Yeah, there we go. So that's what this is. And notice, because it doesn't take a place value, that's why it sits between this column and this column, because these 2 columns are place values. So how do you use it? So that's what we're talking about. So what we're doing is we're counting on the abacus. And this is what the Chinese one. So going back to this one, the Chinese one, this Chinese one is a little redundant, and it's a little much. But why? Okay, so let's start off with clearing our abacus like we always do. That was another thing that I noticed. In school, we teach the children to start with 1, but in abacus, we actually teach the children to start at 0 because we want to be able to. Oh, yeah. Yeah, it's really nice to hear the beads move, but I'm talking too much. Okay, so we teach the children in abacus to start from 0. Why? Because we want to make sure that the abacus is nice and clean. So when we do it, we want to tilt it and we want to push all the top beads up. This is a Chinese abacus. So I'm going to start here and I'm going to start here because then I can talk about 10. So I'm going to do 1, 1, 2, 2, 3, 3, 4, 4, and now 5. Well, this is Japanese, and Japanese made it more efficient. This is 5. This is 5 and only 5. This will always be 5. So, okay. So we have 5. Now, this is 5. This is 5. Why? Just because it's there. I don't know why, but they did it. And then it gets kind of confusing because now I have to think of 2 things to make a 5. Either this is a 5 or this is a 5. But if I keep it at this and I leave it at that, then that's fine. But the problem is it's an extra step because now I got to do this to get 6. So I have 6, 6, 7, 7, 8, 8, 9, 9, and 10. Well, remember on the Japanese abacus, we talked about place value. So the next column over will always be 10. If you start here, the ones, the next one will always be 10. But in the Chinese one, it doesn't make sense because this is 10 now. So this one doesn't necessarily always do place values, but it does. And I'm like, well, that doesn't make sense. So this is 10. This can be 10, but this is also 10. So there's 3 ways to do 10 on the Chinese abacus. And it's like, So people do use the Chinese abacus, and it's a lot of redundant stuff. They don't need to memorize as many formulas, whereas on the Japanese abacus, we have to remember formulas. And one of the formula is understanding how to use the 5. So this question starts off with, and I noticed in the video that I was looking at, doing research and stuff, there's this one question. There was 3 questions, and the 3 question was like 5 plus 3. And I noticed that what they do is that actually they're really focusing on the result. So when we look at on the abacus, it's 5 plus 3, and it's 8. How do I know? 5, 6, 7, 8. We know that all these bottom beads is a value of 1, and this top bead is a value of, this is a master class I stumbled on. Oh, yeah. Yeah, depending on how many questions there are, we might be able to go to multiplication division, but I'm not sure. It depends on how many new people come in and want to know how to start. So, but yeah, you can do multiplication and division, and I was also doing some research on the difference between how it's being done in school and how it's being done on the abacus. And the interesting thing is, there's not a lot of talking and discussion in mainstream school. Anyways, so we're back to 8. So going back to this question, right? This is a simple. In abacus terms, this is considered simple. Why? Because we don't need to worry about any beads. What does that mean? If I add the 5, do I have enough beads to add 3? Yes. So the question that when we start going through the abacus, is there enough beads to add what I want? So when we do abacus, we focus on the process. We focus on our second add-in. Okay. But when I was looking at the video, they were focusing on the result. The next question was 7 plus 1. Okay, well, we know 7, right? We have 7, and then we have the 1. Notice, is there enough beads to add 1? Yeah, there's enough beads to add 1. But the question is, they were focusing on the answer 8. Okay, well, it is what it is. So now, thank you for following the live. Go ahead. Yeah. So the final question was, and this is where it kind of goes into a loop, is a 4 plus 4. Now in school, we are taught to memorize. We were taught to memorize our doubles. You can learn your doubles. You can memorize your doubles. That's not a problem. But in abacus, we don't need to. In abacus, we don't need to memorize our doubles. Why? Because now we're going into how do you add a 4? Notice we don't have enough. Excuse me. Notice we do not have enough beads to add the 4, right? All these 4s are here. So now we're at this one right here. The process that we're trying to do is a plus 4. Now this plus 4 means what? Well, if I don't have enough beads to add the 4, what do I do? Well, now what I need to do is I need to figure out how to utilize the 5. So we have other beads to be able to teach us to do certain things, right? So because we have an extra bead with this 5, how do we utilize it? Well, this is where we have to isolate the variable. And that's math terminology that's being used, but not in the abacus world. We don't call it isolating the variable, but in order to relate to mainstream math, we're actually going to isolate the variable. What variable are we going to isolate? We are going to isolate this variable right here. Now, if you remember algebra, what we're going to do is we're going to have 4 is equal to 5. 5 is too much. When we want to add the 5, right, 5 is too much. The reason why I have this symbol is because I want to add it, right? But 5 is too much. So how do we balance this equation? We have to minus the 1. So what we just did is we isolated this variable. So now what are we doing? We're going to add the 5 and then take away the 1. So that is what we call a... I'm sorry, I completely blanked. In Abacus world, we call it the friends formula. In mainstream, we call it the 5 frame because you're understanding how to use the 5 frame. Every time we do the 5 frame, they show always like stuff. They even have manipulatives like this, right? So if we have 5 beads, if we have 5 beads, if you move it and you separate it, there'll always be 4 to 1, right? If you do 2 and 3, right? So again, we can do 2 and 3. That is where we talk about the addition table. Now, the addition table is, I don't know if it's given to the kids anymore, but I remember we had to do this addition table. And it didn't make sense, like, why we had to just learn everything. But in Abacus, there's a structure to it. So you notice that there is this green. This green is called simple. Why is it simple? Because there's no formulas involved. So here, if I add the 1 and I'm going to add the 5, right? Is there enough beads to add the 5? Yes. So if I chose this, let's do this one, 6. I add the 6 and then I plus the 3. Second add in, I add the 3. Is there enough beads to add the 3? Yes. So all I got to do is add the 3. So now when you become comfortable with understanding how to add the green, which is what this book goes into, like towards the end, and we also do subtraction at the same time. Not those big numbers, but roughly. But we also do subtraction at the same time. So then the next thing we just did is we did 4 plus 4. The pink is what we call the 5 frame. The pink is what we call the friends formula. So why are we doing it this way? Because what we do is we focus on the second add-in. And then the second add-in, right. And on the second add-in, we only focus in what we're trying to do. So that's where this book comes in. So here, again, notice I only focus in on the specific number. What are we trying to do with this bead? So here, if you look at the question, let's say we do 2, right? We have 2. Is there enough to add the 4? There's not enough to add the 4. So I made a little story where I say, okay, well, we got to go to the cats in the tree because cats love to go in trees. There's 5 cats in the tree. So if there's 5 cats in the tree and I grab 4 cats, so I go to the cats in the tree and I grab 4 cats, but then 1 cat runs away. So my answer is 6. Started following you. Happy to see you live. Oh, yeah. Thank you so much for following me. Thank you so much. I'm so happy to accommodate. I wasn't thinking about coming in so late. I didn't think anybody would be awake. So going back, that's why we focus on the 4. And it's the same thing with the 3s. So we have the 3s, but we don't memorize our 3 times table, doubles. We don't memorize our doubles. What we do is we try to understand how to do the 5 frame. See again how it's pink? And this is where the 5 frame. Notice, right, the 5 frame, we have, what is the partner of 3? The partner of 3 is 2. So how do we do this? Well, we have, let me do 4 because it's nice to have it a different number. So we have 4 plus 3. Is there enough to add the 3? No. Well, remember, if I want to add the 3, I go to the cats in the tree, which is 5. But there's too many cats. There's 3 cats I grab, 2 cats run away. And so my answer is 7. It was interesting to try to get it to be to try to get this to relate, because my idea here was that kids will be young, right? The kids are maybe 4, maybe 5, depending if they, if they started with this book. If they started with this book at 3, then they would finish this book in about maybe a year, depending on how strong they are with their numbers. And then they would move on into the +5. So I was trying to get it to be more story-based, a little catchy, so then they can understand how to go into they go into like the story, so they understand the analogy, as opposed to be like, oh, plus the 5 minus the 3. And I had to memorize that when I was learning it. So I made up the story where they goes to the cats in the tree. And one of my students was like, why are there cats in the tree? And I had to remind him, did you not see The Incredibles, where Mr. Incredible was trying to save the cats in the tree? Right? And so I was trying to and then he was like, oh yeah. And it was kind of cool. Yeah. Yeah. Right? And so so that's why I was thinking, okay. Okay, I'm going to tell you this. So there's this one where I started off with the cat house, because I was thinking, I was thinking of cat ladies, right? Cat women, cat moms, or whatever, cat people. And I was thinking, okay, well, cat's like a home. And so all cats are whatever. So then I was like, okay, we can do 5 cats in a cat house. And I was telling this to my son, who I just would, talk about like my activities and stuff. And he was like, yeah, that'd be great. But then my husband heard, and he was like, I wouldn't use the word cat house. And I'm like, why? Well, okay. So one thing is, yes, these books are available on Amazon. You're absolutely right. No, don't worry. Don't be sorry. These books are on Amazon. You can look it up. You can look up this one. It's the only one. It's the only one on Amazon. And then you'll find like the rest of this. I do have others. Depending on how old your children is. This one does 0 to 20, but we also do adding and subtracting. If you're okay with the theme, but we do adding and subtracting. We do talk about the double columns. Yeah, but this one, the Halloween one is only. It's only about bead recognition, and it only goes to 0 to 10. And this one's more about cutting and more activity based, because I wanted them to practice their motor skills and also coloring and tracing. So this was more heavily on like doing more bead and number and word recognition, and it only goes up to 10. So this is one of my activities that I have. Did I make one? I didn't make one. Okay. So this is one of the activities. What does this mean? This is a maze. You start from here. Let me see that. You start from here. And the idea is that they will trace all the numbers, but then they have to figure out if they go left and right or up and down. So if they go here and we're looking for the number 10, they have to write the number 10. So then do they go to the right? No, that's a 9. But then there's this blank spot. This blank spot is where you actually put in items. So I had it where you put in dough balls. I didn't say Play-Doh because Play-Doh is trademark. So I said dough balls. And the idea is to make your dough balls and do 10 of them. And then, one of them is trying to figure out how to put all 10 in that little square. And then after they do this, they go down here because this is a 2. They cannot go here. So the idea is to follow the maze. And the maze is to, try to find their way to the finish line. So when I buy the Rainbow Abacus, on my own, or is it included? It is, you would have to buy it on your own. I do sell it on my website, but you can buy it on Amazon. You can buy it on Amazon. And the rainbow ones, I mean, they're all plastic, and plastic is just fine. There's some that you could spend money, like this one is a bamboo one, but I think this goes for like $30 or $40. Do you need it? No, you don't need it. You can get a nice cheap one. If the color one is too much, you can do the single color one. There's also a bigger one of the colored one in Amazon. I think it does 7 or 13 columns. You could do that too. But I noticed that when the kids get older, they get bored. They get tired of the colors. So I don't know if you want to buy this first and then move to this one. But I think this smaller one, I think that's plenty to do. You could do the extra long one, but it depends on, like, that's a lot of numbers. So going back to the maze. Yes. I like the color one to learn. Oh yeah, I like the color one. I mean, I was working with the brown, I was working with a single color one for more than 20 years, and I saw the colorful one and I was like, woo, I'm going to do that one. But I also really like, I like, just being silly. So that's what that is. And then going back to the maze, so that's what the maze is. And so the idea was trying to find what the 10 was. So here, and they would color it in, right? Or they can't color in this, but they would color it in and they would follow the number of the 10. So that was the maze. But that's, I mean, I, I'm at book 6. I'm working on book 7, but book 7 is actually talking about the -5. So I got to get the -5 out the door, but I do have a +10. So the +10 talks about the late, and I'm not yeah, it's really late. I didn't think anybody would be around. I was just gonna try my luck and see who's around, just to chit chat about Abacus and learn. I don't know. This is some really late learning. But the 10. So we talked about the 5, and now we can talk about the 10. Now the 10 is the same concept. It's about breaking it up. There's 3, 3, 3. Okay, so this is 10. So the idea is, if I have 10, how do I make a 10? And in school, we teach the kids how to make a 10. So if I do 9, right? 9 and 1 makes a 10. Oh, one more thing. I do have a coloring book. I'm getting my books. I do have a coloring book. This one was just me being silly. And I was like, okay, I'm going to do a coloring book. It's really just about Abacus. My whole thing is about Abacus. And so this was like, okay, I'm going to color and see how it goes. And I'm like, that's really boring. This is really boring. What am I going to do? This is dumb. I don't know what I'm trying to do. So then I'm like, okay, this is a coloring book. What am I going to do? And I took it to the next level. I was like, okay, what can I do to make it a little bit better? So I was like, okay. And then I started experimenting. I was like, oh, okay. So then I just kept going, and I'll be like, okay, so I actually haven't done any more. I need to start continuing on. I just been a little busy to try to make more books. But this is my coloring book, and I thought it was kind of nice. It goes to the double digits. It goes all the way to 100. But after 29, it does by tens. So we go 25, 26, 27, 28. I mean, it's a lot of Abacus. But here, it starts to go into 30, 40. I think it's about 80 pages. 30, 40, 50, 60, all the way to 100. And the way I have 100 written is the same thing. If this is the ones, this is the tens, this is the hundreds. And the idea was to like understand that this is the frame, right? And this is the beam. And I use this the abacus, the template of the abacus, to help the children understand that when you have this line, when you have this bar and one bead is touching, then that's the bead that we count. So this is the counted bead. And that's it. That's the end of the coloring book. So we have the coloring book, we have the +10s, the +5s, the Halloween one, the counting Christmas one, and then we have the Abacus preschool one. This one, the Abacus preschool one, was my first one that I ever did. And so what I did was talking about how to read the numbers and how to understand what the bead recognition is and all this and that. And then it goes into adding and subtracting. So notice I have the adding here, and then right after adding we do subtraction. So the kids know how to subtract right away, because when we get to the +5, which is what we did here, right? Notice we have to already take away the 1. So we can't wait on doing subtraction. We have to balance it out. Once you know how to add, you will know how to subtract. So this one was like lesson 10. This is lesson 10. It goes -1, -2, all the way to -4. And then we do lesson 11, and we do the adding of the 5. So adding of the 5 is just this. We plus the 5 minus the 5. That's all we're doing. We're adding the 5, taking away the 5. But again, we add the 5, and then we add the 6, and we add the 7. The numbers, the questions don't get too complicated, because you can only do so much with the numbers, right? Because we do 9. 9 is 9. There's nothing else after that. But again, when I did do this preschool one, this is talking about only simple addition. And that's where this comes into play. So this book is the +5, which is this, right? Which is that. Now Now, when we do the plus 10, notice that there's more questions, more numbers to worry about. So these yellow here is the plus 10s. And the plus 10s is when we start doing the 10 frame. 2 plus 8 is equal to 10. And it's the same idea. So when we look at it, let's do 5, because 5 is easy to understand. So we do 7. We do 7. So I have my 7. I want to plus the 5. Notice they don't have enough beads to plus the 5. So what do? Well, we know we cannot plus the 5 here, right? Because we're already using it. So what can we do? We can use the 10. So that's where I have this explanation. Notice that says 5 plus 5 is equal to 10. That's how we make a 10. When we make a 10, okay, so we know what we're going to do is we're going to utilize this. So we have to take our 5 and we got to move it to the other side. So we rewrite the question saying if we want to add the 5, we have to plus the 10 and then take away the 5. That's the easiest. That's one of the easiest formulas, right? Because it's easy to do the plus the 5 minus the plus the 10 minus the 5. Plus the 10 minus the 5. Easy. So that's one thing. And then, there's the opposite. If you minus the 5, you minus the 10 plus the 5. So if the question is, let me see a question. Okay, yeah. So if I do 12, right? If I do 12 and I take away 9, well, I can take away the 10, right? I take away the 10. How do you make a 10? It's a 10 and a 9. 1 and a 9. So it's take away the 10 and you plus the 1. And then because I do this, the kids will see the number pattern. When I want to add the 9, are you at Barnes & Noble by any chance? I am not, actually. Not yet. When I make a little bit more money, I do plan on trying to expand out to Barnes & Noble and have my own ISBN. But this is still trying to break through the industry. So it's a little harder to get into because not everybody understands what an abacus is. And this is what it is, right? Like I'm trying to teach everybody how to read the abacus and how easy it is. And so, and that's one of the things. So thank you again for following me. Cats in the tree. Yeah, cats in the tree. No, this one is, so this one is funny. I actually made this one more space theme. So this one was asteroids. How do I have to go to the asteroid belt? So if I do 6 plus 5, do I need to go to the asteroid belt? Yeah, because I don't have enough beads to add the 5. So I have to go to the asteroid belt that's over here, and then I have to take away the 5. And so my answer is 11. Yeah, it is a very visual learning. And so that's what it is. In Abacus, we actually do the questions on the Abacus before we take it away. Because you have to go through the motions and see how the beads move. When you see the beads move, it's a lot easier to understand how it gets done. So, I mean, if we're okay with this, we can carry on to doing multiplication. But I noticed, hey, Darbug, I didn't see you in there. So that was the thing, is like understanding, hi Nick, understanding how to do, just to see how everything is. And so that was the one thing, like one of the things to understand, like when I want to add 7. So if I add 7 and I want to add the 5. So that was the one thing in school, we're always pushing the kids to understand what this symbol is. This number is just a symbol, and it's difficult for the kids to understand what the symbol is. But on the abacus, you see it. You see that it's there. So when I do my number pattern, they will know that I need to plus the 10 minus the 5. So it's really quite interesting to see that click for them. And they notice that if I do this pattern, I know I'll get the correct answer. And that's the one thing that was kind of interesting when they start going through that path of seeing there's patterns in math. Because that's the thing, right? Like one of the things in math is like trying to figure out the pattern. Well, that's great. It's great that the school is teaching the kids how to do pattern recognition, right? But then when we start giving them numbers like this, is there really a pattern? So when you see it on the abacus like this, that's a pattern. So that's the interesting part about it. So yeah, I started going into other things. Anyways, so, do you have any questions? We can continue on. I mean, I could talk about abacus all the time. I can philosophize about abacus too. Because I noticed that there's a lot of things that happens with abacus. No, sorry. There's a lot of things that happen in math that we do that we don't realize that we're doing. So one of the things was to push the kids to understand what the symbols are. Whereas on the abacus, you can see it, and it was and so so yeah. I mean that was one thought. The other thought was we can go into um, adding. You want to do more adding of the 10? Oh, 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 or we could do our two-step problem. So this is a two-step problem. Why is it two steps? Now, okay, that was the other thing, is trying to understand the math terminology. This is a two-step problem because now we're actually going to be figuring out how to work this. There was one parent that was like, well, I want my kids to know, and this is, she just started. And she was like, well, I want my kids to know like 5 plus 8 and 8 plus 5. I was like, well, yeah, but it's also a little bit tricky. So the question was, why is 8 plus 5 different than 5 plus 8? We don't focus on the result, right? That's not what we're working on. What we're working on is the second add-in. So when we look at the second add-in, it's how we do it. So this 5 would be over here, right? Notice it's a plus 10 formula. So the plus 10 formula, it'd be easy. Plus the 5 is equal to plus the 10 minus the 5. In Abacus, we write the symbols. The reason why is to remind us what we're trying to do. So here, when I do 8, right, I do 8, I want to plus 5. This is what I'm doing. I'm plussing the 5. So I need to plus the 10 and then minus the 5. So it's already written out for me. All I got to do is follow the steps. So my answer is 13. Okay, so now we're here. Okay, we have a 5. We add a 5. But it's loaded. This is where we do the two-step problem, because now we're working on with the second add-in. With the second add-in as an 8, if you notice, it's plus 5 is equal to 8. It's white. Do you see that? I don't know if you can see that, but it's not colored in. So right here, that means that this is there's a two-step equation. What does that mean? The first thing to do is understand when I want to plus the 8, I need to plus the 10, right? Plus 8 is equal to plus 10 minus 2. So I plus the 10 and I take away the 2. So I'm going to plus the 10 before I forget. So now I want to take away the 2. If I take away the 2, there's not enough beads. I'm a little crooked. So if I want to minus the 2, I can't because I don't have any beads to take away. That's the one question. Is there enough beads to take away? So no, there isn't enough. So what's another way to minus the 2? Remember, I have this 5. We didn't touch on it, but we have this 5 that we can do. To know, just like how we did plus 2 is equal to plus 5 minus 3, we can also do the opposite. Minus 2 is equal to minus 5 plus 3. Right? So we can do is minus the 5 and then add the 3. So this is our two-step, because this is not simple anymore. It's not just, is there enough? We can't add it. We can't take it away. So now we got to do is we got to add our 5 formula. So if that makes sense. That's the two-step. And the funny thing is the two-step, I was listening to a friend of mine, and she is a math tutor. So if you're looking for an algebra tutor, I know somebody. And she was talking about isolating the variable, and she was doing all these terminologies that make a lot of sense in Abacus, and we don't do that in Abacus, which is interesting. We don't have terminologies like the 5 frame and the 10 frame. We just talk about it as big friends and small friends, or family and friends. Like, they have their own terminology. So my goal was to try to make it more mainstream so it's easier to understand. So again, we have our minus. So this minus, right, we still keep the sign so we have a reminder what we're trying to do. That's why we keep the sign there. And is it negative? Yeah, it's negative. Because we have to take it away. But we don't really deal with negatives in Abacus. It's all, because you can't really do negatives here. So, anybody have any questions? Do you have any more questions, MM Wifey? Any other questions? We can continue on. I mean, we could talk about multiplication if we're okay. So that's the two-step problem. That's the two-step right here. But if you know this, if you know the green, you know the pink, and you know the yellow, you can do all of the numbers. It just depends on how it all fits in. So what does that mean? Well, if I do 49 plus 3, okay? 49 plus 3. Now, this is where we get a little bit more advanced. The kids, I mean, this is later on, right? The kids are starting to do double digits and how to move things. But this is, I'm talking to adults and we can keep up. So we do 40, we do 9, not a problem. Now we do the 3. Okay, when we add the 3, is there enough to add the 3? No. Is there enough to add the 5? No. Is there enough to add the 1, to add the 10? No. Is there another way? Yes. What does that mean? Okay. So the basic here is this is another two-step, but this is more complicated two-step because now we're dealing with two columns. Did you want to do a simple two-step, which is one of these? Maybe we'll do one of these. You know what? You're right. I can tell. Okay, let's do this. So we got 49 plus 3. We want to add the 3. Now, notice I don't have enough beats to add the 3. So I don't have enough beats to add the 3, but I don't want to add a 5 because I already used a 5. So my next one, the only other ones you have to do is plus the 10, right? Minus the 7. You plus the 10 minus the 7. This is the only other formula that you have to memorize. So I need to plus the 10 minus the 7. Let me minus the 7 first, right? I take away the 7, so I'm done with this. Now I need to plus the 10. Well, I don't have enough beats to plus the 10. Now the thing is, what's another way to add 1? The only reason why we say plus 10 is so we know that we're going to the next column. That's the only reason why we do say plus 10. But if you really think about it, it is just plus 1. So if we want to add the 1, do you remember if I don't have enough beats to add the 1, I can use the 5. So remember we had the 1 plus 4 is equal to 5? Well, when we isolate this variable, we're going to do plus the 1 is equal to plus the 5 minus 4. So we do plus the 5 minus the 4. So my answer is 52. So that's the other two-step because this is no longer simple. And it gets it gets more convoluted, right? So then my answer is 52. So, visually seeing it, that's what we do. And you build on this. You build on understanding the 5, you build on understanding the plus 10, and once you get that solid, then you can mix and match. So a lot of it is understanding it and how to mix and match it. Wow, I've been on for about an hour. I can't believe it. Okay. So again, it goes to another step. So, that was the thing. So this 10 is like carrying over. That was the thing I was going to say. So in school, we talk about carryover. And that's what we do in Abacus naturally. Doing a carrying over is naturally part of Abacus, so we don't have to think about it. So what does that mean? Well, let's do another one. Let's do another one. Let's do 99 plus 4. Right? Now we're going into more steps. What does that mean? Well, we have 99 and I want to add the 4. Is there enough beats to add the 4? No, there's not enough beats to add the 4. So what am I going to do? I'm going to add the 4. Notice I can't add the 5. The only other one is plus the 10 minus the 6. This plus 10 minus the 6. This is my carryover. So I want to take away the 6 so I don't forget. And I want to plus the 10. Can I plus the 10? No, I can't plus the 10. What's another way? So remember we talked about 9 plus 1 is equal to 10. So what we're going to do is we're going to isolate and move this 9 over. So it's plus the 1 is equal to plus the 10 minus 9. So I plus the 10, which is carrying over, and then minus the 9. So my answer is 103. So, yeah, I mean, that's what this is, right? So this is So if I did it the way school talked about it, it would be, 3 plus 1, and then plus 1, there's a 9 here, and then that would be 10. So that's how we do it here as well. So that's the difference between doing it through the abacus and doing it through regular school. Yeah. So that is also a two-step, but it's more two-step, right? Because now it's not. It's still the same two-step because what we're doing is it depends on if we're going to be plussing a 10 or plus the 5. So it depends on it depends on what you have and where you're going. So the biggest question is do I have enough? If I don't, how do I get there? Oh, my live is going to end if I don't. Oh, I don't know. No, I'm going to have to figure this out. Uh-oh. Nope. My internet says I don't have anything. Oh, there it is. Let me move that over. There we go. Uh-oh. Let me move it over. I'm just verifying my inactivity. Can I multiply? Yes! Let's do some multiplication. And I'm going to do a comparison. Oh, this is brilliant. So I was doing some research because I was getting kind of like, I didn't think I was going to be doing multiplication on the abacus to show people, but a lot of people were able to track. So if you can track it, then that's great. So what we can do is we can do multiplication. And multiplication, I noticed, is in 5th grade. 5th grade math. That's what we're doing. 5th grade math. Now, I'm so pumped. Let me know if I'm too loud. My family's probably still awake playing games and computers. Okay, so what are we going to do? We're going to do this one. It is 436 times 4. Now, in regular math, what you do is you put it and you line it up like this. You got to make sure that I just joined and I think I started to undertake how 99 and 3 was represented. Yeah, fantastic. That is great job, Intense. Yeah, and it's easy when you see it, right? Because it makes a lot of sense. Because you do 1, 2, 3, 4, and then when you start knowing, and that was a cool thing. Like my kids, when they started doing Common Core math, they didn't have a problem because they was like, oh, all we're doing is the same thing what we do in Abacus, but we can visually see it. So in school, they're trying to be more visualizing. Okay, so now multiplication. The first thing that we need to do, because I notice, is we in Abacus need to know where our starting point is. Where are we going? Why do we need to know our starting point? Because we need to figure out where are we going to put our answer on this column. You could put it here, but then you'd be running into decimals, right? So the idea first, and the one rule is to understand where are we going to put our answer. Now to find out, we do 1, 2, 3, 4. We combine these digits and we know we're going to start over here, right? Okay. Now in Abacus, how we're going to do it is exactly how we're going to do it in regular math. We do 4 times 4 first, and then we do 3 times... Oh, so we're doing it forwards, whereas in school we do it backwards. What does that mean? So we're going to start with this. So we start with 4 times 4. 4 times 4 is 16. So we add 1 and we add 6. Okay, I move my finger over because this is where I landed, right? Because I have the 6. 1 and 6. The next thing I'm going to do is 4 times 3. 4 times 3 is 12. I have to think about it. Is 12, right? There's my 1 and there's my 2. All right, so the next thing I do is 4 times 6. 4 times 6 is 24. So I add my 2, right? I add my 2 and my 20, and I go to the next column, I add my 4. So my answer is, who knows this answer? Typically, I do it forwards in my head anyway. Yes, exactly. So that's the thing about Abacus. We actually do it forwards. But in school, we don't do it forwards. We do it backwards. So who can tell me what this number is? If this is my 1s, this is my 10s, 100, yeah, exactly, 1,744. Yep. Okay, so in regular school, what I notice is that they do 6 times 4 is 24. So we have our 24, right? But then we have to do the carryover up here. So 4 times 3 is 12. So 12 plus 2 is 14. So then we do the carryover here. 4 times 4 is 16, and then you add the 1, it's 17. So notice it goes backwards, whereas in Abacus, we actually go forwards. Oh, wait, I get it now. Yeah, yeah. I mean, it's really kind of interesting on how everything works. So in school, it's interesting that they go backwards. They start off in the ones first, and then they do the tens, and then they do the hundreds, and then they do the thousands. But in Abacus, we start off with the thousands first. We start off with the thousands first, and then we count back, and then we multiply it out. But then you can go backwards too. You can, but it's not natural. So let's try it, right? 36 times 4. So we do, if we start here, like, okay, that's fine. So we do 6 times 4 is equal to 24. 24. But now we got to do 24. So notice I have to do 1 step forward and then 2 steps back, kind of a thing. So I add 20 and I add 4. So then the next one is 4 times 3. So 4 times 3 is 12. So I do 1 and then I do 2. Right, because I have to go forward first and then go back. So it's kind of like stepping back. So then 4 times 4 is 16. I go 1, I add my 1, and then I do my 6. So it is possible, but I feel like it's better to go just forwards. Yeah. Yeah, exactly. You go towards and then you go back. And I think it gets a little confusing because because the next thing is when you start doing double digits, right? It's easy to do it when there's 1 digit over here, but let's say we do double digits. Let's say we do 436 times to 48. Let's do that, right? Now we get a little bit more complicated. So I don't know if we were going backwards where we would start. I would have to think about that. Because, okay, so let's do it our way. Let's do it the Abacus way. So again, we need to find our starting point. 1, 2, 3, 4, 5, right? We start at 5. 1, 2, 3, 4, 5. Now, again, we're going to do 1, this one, and then this one. Then when we're done, we have to reassess to figure out where our next one is. I mean, I would have to really work it out, but it's not. I would have to work it out how to do it backwards. But because I'm used to doing it forward. So we're back to here. I'm going to do 1, 7, 4, 4. We know that, right? Because it was here. 1, 7, 4, 4. So now we've already done this. Now it's time to do the 8. So we have to reassess where we're going to put the answer. We do 1, 2, 3, 4. So I count 1, 2, 3, 4. Okay, so now I do 8 times 4 is equal to 32. So I add my 3. I can't plus the 3, so I have to plus the 10 minus the 7, and then plus 2. Cannot plus 2. I have to plus the 5 minus the 3, right? And then I do 8 times 3. 8 times 3 is 24. So I do 20, and then I do 4. Not enough. I add the 5 minus the 1. So then I do 6 times 8. 8 times 6. 8 times 6 is 48. So I do 4. Not enough. I need to plus the 10, take away the 6. And then plus 8. So that's my answer. See how it's different? Start at the 6th spot. Yes, you're right. Start at the 6th spot. Yes, you're absolutely right. Because that's how 1, 2, 3, 4, 5. No, start at the 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, because it's 5. 1, 2, 3, 4, 5. So that's where we start. But going backwards, it gets a little confusing. Like I would really have to think about how we do it backwards. Yeah. The answer is 2, 0, 9, 2, 8. Yes, exactly. That's what it is. Thank you, intense. Is tense. Extense. Extense. Yes, that is absolutely right. So yeah, we could do it backwards, but then I'd have to really think about like how to do it backwards. Anyways, so usually we do it forwards, and it's just easier for me because I've been doing it for a while now. But that is multiplication, and that's multiplication with double digits. So again, it's the same thing. We had more and more digit, right? And it would just be bigger. But then I'd have to change my abacus. And I don't want to change my abacus. Okay, so, oh, existence. That's brilliant. That's brilliant. Also, couldn't you start all the way at the left all the time? You could, but then you don't know where you're adding because you don't know where the decimal place is, right? So like let's say we'd started here, right? This would be 1, 2, 3, 4. This is 4. 1, 2, 3, 4. If I started all the way here, then I'd have an extra 0. So you could, but then you'd be off by a column or so forth. That'd be not, it wouldn't make sense. I'm saying you say start forward, then work backwards to the, yeah. So we start from here and then we work backwards. Yeah. Yeah. I was thinking about like, what if we did that and it'd be just difficult because, um, yeah, because then you're just in the wrong place value. And then, obviously zeros mean a lot. So, I mean, I was trying to figure out like other ways to do this and how to make it relate to mainstream math. And I noticed that, and that was the one thing to do, like research. I mean, it's been a while since I've actually done, fifth grade math, and I didn't do fifth grade math with my kids because they already know all this stuff. So it's not like I really needed to like learn, didn't not learn, but needed to remember. So going through this path to try to make it more mainstream, I had to go back and figure out, okay, how are they doing it in mainstream school and how am I doing it in Abacus? So I noticed that, they go backwards and I'm like, that's interesting. And then, we still have the same terminologies, but we don't talk about it in Abacus world. We don't say that this is the factors and this is the product and we don't have terminologies like that. We just say, do the number, do the question, you'll be done. So, oh, fantastic, I'm hooked. Oh, good, existence. Yes. I want to know more about the abacus. Yeah, oh, funny. When you write, I don't know if you have an iPhone. When you write on the app, on the phone, I don't know if this works for you, but like, let me see if I can do a new one. Okay, but like, if you said math, do you notice that there's a little abacus here? It was interesting, and nobody knows. I mean, nobody knows. I think Abacus helps us do mental math. Yeah, it does help. So if you look at this, I don't know if you could see it. Ooh, that's wrong. If you look at this, you know what? Here is your homework. If you could take a look at what this is, you can actually read what the number is. The number, yeah, the abacus in here is a different abacus. This is the Russian abacus that's inside the chat. That goes to like the 10 beats across, and we don't like it goes like this, and there's 10 beat across. And I don't know how they do place value, but it's how they do it is I think is just the quantity. But oh yeah, it's like 1976. You're absolutely right. 1976 is the year that that Apple, was it Apple or the abacus icon came into effect. It was something like that. It was something crazy like that. I was like, oh, that's cool. And then I think the Windows Abacus had one too. Yeah, I was doing research and I was like, oh my god, that's funny. Oh. So let me go get my little abacus is everywhere, and I don't know if you guys noticed it. Let me see if I can find my presentation, and I see if I can show it to you. But it was kind of cool. So, because I'm trying to relate it, I'm trying to relate it to everything, right? And so I found this one where abacus is everywhere, and it's really kind of funny. Anybody seen the movie Willy Wonka? Let's see. I think this is it. Yeah, we'll do that one. So, hopefully you could see that. Let me see. Where are you? Okay. So, 1,000 times out of... Okay. So, Willy Wonka. Do you know Wonka? Let me see. There we go. Wonka. Wonka? I'm getting an obvious. Wonka has a character. And the character name is Abacus Crunch. I thought that was kind of funny. And I was like, oh my god! Abacus is everywhere. And so that was one. Okay. I have another one. Anybody know this one? Right there. There's an abacus right there. There, one of the penguins, I don't know, I think his name is Rocket or Rocky or whatever. He's holding a Chinese abacus. I mean, he's holding it wrong, but he's still holding an abacus. And then notice, and that was a penguins of Madagascar. Yeah. Oh yeah, that's what Kawasaki. Yes, Kawasaki. So he had an abacus, and then my kids were playing this one game. It's called Empires and Puzzles. It's some sort of matching game, which is kind of cool. And he noticed, it was funny. He noticed that one of the characters was a pulverizing abacus. I'm telling you, abacus is everywhere if you really look at it. Abacus is everywhere. You just gotta, if you just paid attention, it would be like, oh my gosh, why? So then the next one was a book. So one of my friends was really interested in this one book to teach to his child, and this lady, this young girl, she had big dreams. She's blind, and what they did is they homeschooled her. And this is an older book, but it's one of those stepping stone books. And in the book, it says that they actually make an abacus. They made it out of acorns, so they had needles to make an acorn. It is a new old thing, and I'm trying to make. Oh, that was the thing. The reason why I'm working really hard with my worksheets is because I'm trying to modernize Abacus. I'm trying to modernize it to make it more engaging. So, the next one was this one, which was I don't know if anybody's played Match Factory on their phone, but I played Match Factory. Oh yeah, you're welcome. So I was playing Match Factory and noticed. Anybody notice anything here? Oh, thank you so much. I do appreciate the compliment. MMA wifery. I think you're doing it. I hope I am. I hope I am, but it's fun. It's fun and it's exciting, and I've been doing it for so long, but I think it's to a point where I'm trying to relate it to the mainstream math. But anybody see that? Yeah, it's there. Isn't that funny? Like, you would think, why would they put that there? But people see it in their preschool classes, but they never knew how to use it, which is fine. But it also adds to the number sense. And the interesting thing now is, now as school goes through, they're trying to make math more visual. That's why you do like the array blocks and how to, count and do multiplication and so forth. So yeah, so that was the one thing, was just, and that was it. That was my little thing, that abacus is everywhere. Oh yeah. Oh, neat. Oh, which fighter is he? Did he ever go to the octagon? That's crazy. Yeah, my husband and I would watch it. But that's as far as it goes. I named one of my kids after an MMA fighter because I think he was cute. Oh, anyways. 20 plus fights. Wow. Which one? Matt Hughes. Yeah, he was pretty good looking. But then he got into a car accident. He got into a tractor accident, and now his brain's all crazy and stuff, and he gets like really crazy. And he divorced his wife because he was just all over the place, and it was kind of sad. But yeah, he got injured. Yeah. Yeah, I mean, I was watching MMA for a long time when it first came out with Dana White. Now I don't know who it is. Yeah, I mean, we're all getting old too. But yeah, his was a tractor accident, I believe. Chris the Enigma. Oh, huh. I, I, I don't follow MMA like I used to. I will have to look him. I will look him up now. Oh, it's still under Dana White. Yeah. Okay. Okay. Is Joe Rogan still emceeing? Yeah, I know. Oh, okay. Yeah, since yeah. I mean, I was watching MMA when I didn't have any kids, but now I have kids. I don't watch as much because busy with kids and stuff. So, well, good luck to him, and with all the matches and stuff. Woo, that's a good one. But yeah. So going back to this, I mean, we could do. You know what? Let's end off with some division. Nice to meet you too. You want to end off with some division? We can do division. I don't know if it's too much. I mean, it's a lot. I mean, this is a lot. This is like, oh, okay, cool. But don't forget, it is a lot of information. And, obviously the books are to help solidify and also make it easier. But they're for kids, really. So here is the problem that I have. And I was prepared. Okay. So again, we need to figure out where our starting point is, because what we're going to do is we're actually going to put our dividend onto the abacus. And in order to figure out where we have our answer. So to do that, we have 3, but it's -1 because it's dividing. So it's a minus. So 3 take away 1 is 2. So I start at the second column. This is where I'm going to put my answer. I'm going to start my answer. So to start my answer, before I do that, I have to put my dividends over here. So I add the 9, I add the 3, and I add the 6. I'm talking slow just so we know where it is, because it gets a little confusing when I start moving around and stuff. So what I notice in school is we don't do a comparison what we're doing here. We teach the children are just taught how many times 4 can 9 go into, which is it's not a great question. I think they could have done it better with the question. Which is what times 4 is equal to 9 or less. That makes more sense to me. So in Abacus, we don't talk about how many times does 4 go into 9. We don't say it like that. We say what times 4 is equal to 9 or less. 9 or less. We can't do more than 9, right? It has to be less than 9. So in order to figure this out, I mean, that's easy. Now, oh, I'm sorry. I forgot. What we do is we have to compare our first digit. Which is bigger, the dividend or the divisor? If the dividend is bigger, then we got to start over here. We're going to skip a column. That's just one of the rules that we have to know. If the dividend is bigger, you skip a column and you start here. I will do this again in the regular mainstream math. So now we do 2. So because I have here, I know my 4 times 2 is equal to 8. 8. So I put my 2 here, and then I have to take away the 8, just like we have to take away the 8 here, right? So I go over here and I take away the 8. Notice I still have dividends, right? I still have dividends, so that means I got to reassess. I got to compare again. Now, instead of comparing this number, I have to compare this number. That's this one right here, right? That's the 1. But notice my divisor is bigger. If my divisor is bigger, then I have to bring down the 3. I have to utilize the 3. So the question is, what times 4 is equal to 13 or less? So 13 or less, hey Skywalker OG. So 13 or less, 4 times 3. 4 times 3 is equal to 12. So what are we going to do? We're going to add 3 to this column because 3 is my answer. So I add 3 to this column and I take away 12. I take away 1 and take away 2. Again, I still have a dividend. I still have a dividend. So I got to reassess again. Oh, 1 and 4. Who's bigger? The 4 is bigger. My divisor is bigger. So I have to take 2 of these columns. 1, 2. How do I know? Because if I do 12 and I take away, right? Because it's 1. You can't take away 4 from 1. So I know that now the question is not how many times does 4 go into 16. It's what times 4 is equal to 16 or less. Because we know our math facts. We know our math facts solid. We know that if 4 times 4 is equal to 16. We know this. We don't know 16 divided by 4 is 4. We don't learn it this way. We don't memorize it this way. We learn it what times 4 is equal to 16 or less. I mean, we don't have a dividing table. We have a multiplying table. Anyways, so we have 4. So I had the answer is 4 and I take away 16. Take away 1, take away 6. And that's how I do division on the abacus. It's very visual and it's taking away stuff, but it's also understanding the place value and moving. And that's what we don't really do, because you have to make sure that it lines up, because if it doesn't line up, then you're kind of crooked, and if it's kind of crooked, then you might like miss a step. So why didn't we have, exactly, right? We don't have a division table, but we have a multiplication table. So that's why I don't understand is, why are we saying how many times does 4 go into 9? I'm like, who talks like that? Okay. I mean, they talk about the concept of dividing and stuff, but yeah, we don't have a division table. So that's it. The answer is yes, 234. Yeah, because if you notice, in regular math, we use this number. We go here, 2, right? And then we bring it down, and then we're here. We have to go to the next column over, and we do 3. And then we bring it down, and we do 4. Yeah. Thank you so much, existence. Yeah, it's been about an hour and a half. Woo! Who would have thought? Masterclass in Abacus. But yeah, I mean, this is the rundown, and when you get to understand this, everything is pretty easy. And then the funny thing is it is a gateway, because in Abacus we go through a checklist of what can we do, what can we not do. I don't understand why we don't talk about this in school, right? Like, we don't talk about, let's compare our digits. We just look at it and be like, can we do it? But in reality, in Abacus, there's more logic to it. Like, who is bigger? Is this bigger or is this bigger? Well, if this is bigger, then just move it over. If this is bigger, you know what I mean? So it's kind of like, Abacus is so logical, but the questions that we use in Abacus makes a lot of sense, that I don't understand why we don't use it in regular mainstream math. Added to cart. Oh, woo! 3:49 a.m. Yeah, that's kind of late, and I didn't think anybody would be on. Thank you so much for the likes and the hearts and the follows. Thank you so much, everybody. I do appreciate this, and I'm happy to be able to converse and talk about it. I'm glad you guys were coming along my ride. Only the smart one. Yeah. So, but yeah, I mean, once you could do square roots and stuff, but I don't know how to do square roots on the Abacus. I went as far as to division and multiplication on the Abacus, and then by then the kids are in 5th grade, and when the kids are in 5th grade, then they're going to start using the calculators, because by then hopefully they understand how to do more advanced math. So, hi, Mustache Matt. How's it going? We were just talking about Abacus and how fun it is. But yeah, I mean, there's a lot of numbers flying around, but when you start understanding how to utilize it, it's really kind of interesting on how simple everything is. It looks like it's a lot, but it's actually quite simple when you understand like the fundamentals. Yeah. So, anyways, it's already an hour and a half, and I was wondering if anybody else had any more questions. If you have no more questions, I'm going to head off. I'm going to turn it off. That's how my brain does the math in my head. Oh, yeah. That's fantastic. So then using the abacus would be a natural progression, right? Because that's what it is. Abacus is a natural progression, and it goes into, more complex math. So, yes, you too have the lovely rest of the night for you too. I do plan to come on board, I think 7:30. Can you show how to do it again? Yeah. 7:30 in the morning, Pacific Standard Time tomorrow. I will be here. So I'm just going to do a real quick rundown on how to count. So when we count, it's the ones place. The ones place is here by the dot. I'm going to choose this dot and not this dot. I mean, actually, I'm going to do this dot, so then we have a smaller number. Because right here, if I use this dot, there's going to be a place value. Right, the decimal. The decimal will be between these two dots. So when we talk about it, we count 1, 2, 3, 4. Right? So we have 4, and then we have 5. And then 6, how do I know 6? Because all the top bead will always be 5. This is 5, 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 right? So these are all 5s. So when we count it, we have 5 and then 6. So it's easy to say we have 7. 5, 6, 7. And then 8 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. So what's 10? Well, when we know that this is the ones column, we know that 10 will be over here. And that's 10. Just like how we write 10 regularly, right? 10. Or no, that's 100. That's 103. 10. So 10 is, this is the tens place, and then this is the ones place. Just how we write it is how we have it on the abacus. So, but I'm gonna Bree Marie, I'm gonna sign off. If you want to join me again, I'll be in 7:30 a.m. Pacific Standard Time. I'm gonna try to get some sleep. It's been a fantastic night. Thank you again for everybody joining. Yes, you too. You too have a lovely night. But again, if you have any more questions, come with questions. But I do plan on coming on board. I believe I said 7 a.m. Yeah, there we go. 7 a.m. Pacific Standard Time. Be there or be square. But if you're sleeping, that's fine too. But it's going to be the same thing, right? I've done this multiple times, but it's the same thing, same questions. It's all the same. It's all the same. Oh, you're welcome. You're welcome. Yeah, it's all the same. And then there's the books. So, the books, I'm still working on book 7. I need to work on book 7 because people are starting to buy book +5. So I got to do +5. I got to do -5. So I got to put my butt into gear and do the -5. And then the -5 I did was flowers in a pot. I don't know if that made sense, but I did flowers in a pot, and it's the same thing. So not the same thing, but the questions are different. And then this is a maze, and this maze is like you answer the question, and then you figure out where your path goes. And the idea is to try to get to the finish line. Oh, sorry, there it is. And then this one was a tic-tac-toe. Pick a number, pick a place, answer the. That's what I did. So this is what my book is. This is the +5. I got to do the -5, make that book, and then I got to do the -10s. So, oh yeah, thank you. Yeah, it was I do enjoy the process. And what's going to happen is when I go through the book, what I'll do is I'm going to start editing my book live, because that's what I did for this, and I made sure to make all of the questions make sense. So all of these questions that I have, I went through it on one of my previous lives, and I made sure that all of the activities make sense, because it would really suck if the questions don't make sense. So this one was the maze, and then this one was a hidden number, and I made sure that I try to make the best to make sure that the word makes sense. This is more space theme. So this one was like starship, I think it was. And so you answer the question, you take the number, you take your answer, take your letter, and you find the answer down here. So that was it. And then there's this puzzle. So you have a puzzle board, answer the puzzle, find the answers on the puzzle piece. So it's activities to strengthen the concepts of what's in this book. So that's why I broke it up into specific like +10s and then +5s. Oh yeah, thank you. Yes, perfect for the kids. I hope it is. My students that do work with it, they do enjoy the activities. Yeah, and so I gotta keep going. I gotta keep going and build whole slew of things. I might get one of these for my nieces and nephews. That'd be fantastic. If you can teach them, teach them the basics of like how to do the abacus. And then since they're going to regular school, you can tell them that if they can, you can use their regular math with their abacus. That's what I used to do with my children. If they had a problem with class, I would say, you know what, get your abacus out and start working with it. And so they would take they did multiplication. They had to do like multiplication, whatever, right? And they get the answer wrong. So what I said is, okay, you know what? Take your abacus out and let's do it. So you have to ask the teacher if it's okay to bring the abacus to school. I don't know how old your nieces and nephews are, but with my schools, in my teachers, my children's teachers, they allowed it. But even if they did not allow it, you can do it at home, or they can do it at home. The one thing I do tell my kids, though, is that they need to show their work, because if they do not show their work, the teachers doesn't understand what they're doing. So no matter what, they still need to show their work, even though they do it the abacus way. So if they do it the abacus way, they can do it as they could do it like a check, yeah. double check your answer through the Abacus way. Or if they get stuck, do it through the Abacus way and then try to figure out how to rewrite it the way they're taught in school. But I'm not here to say only do the Abacus. What I'm here to say is this can supplement and help assist to learn their stuff. You know what I mean? This is not end all, because it only goes up to multiplication, division. You know, you still need to go through and understand algebra and calculus and trigonometry and stuff. An analog, yes, it's an analog calculator. Exactly. Actually, it's just a bunch of bead counting. Really, it's just bead counting. But it's how do you work the beads, and it's in all the logical steps in the checklist. So yeah, I mean, whew, I can talk and I can philosophize a lot about abacus. But I do like it. I do think it is the greatest thing next to sliced bread. Am I great in math? I don't memorize numbers. I think I don't work well with numbers, but I can do my abacus. I can teach it. I can do it. My kids are super fast, but I have to slow them down if I wanted to see what they're doing. All right. Whew. Okay. If there's any other questions, let me know. But I'm going to sign off. I said that already. It's already an hour and a half. I don't want to take up everybody's time. But it's been a while. Thank you again. Thank you again. I will be on 7 o'clock, 7:30 Pacific Standard Time tomorrow. Tomorrow I'll be on, because I figured out a way how to go live. I couldn't go live early today because I was like, I can't do it on my phone because I don't have 1,000 followers. I was like, what? So I'm now on my computer, but I can do it on my computer. So I am here. And I do think that, seeing this is better than seeing all the posts. Like, if you look at my profile, it's a post about abacus and all it is. So, but that's what I'll be here. 7:30. If you want to join, it's fine. If you don't, that's fine too. It's good. I'm here. And let me know if you have any questions. Thank you again. Thank you again. I will sign off. Thank you. Thank you. Have a good night. Thank you for the hearts. Thank you so much. Yeah, if I'm awake. Yes. If you're awake and you want to just talk about abacus, I am here. Have a good night. Have a good night. Bye everybody.